Okay guys, before we start this video, guys, make sure that please you subscribe to this channel, you like the video, and also share the video. Okay, let's start. So into the video, we'll talk about the concrete reinforcements using Matlab, right? And before I start, I'm gonna just give a basic understanding about the concrete, right? So the concrete is just a mixture of sands, and other aggregates, right? Like gravel, water, right? And we know that the concrete is strong in compressive forces. Like if you compress this concrete, it's gonna resist, right? But it's weak in tension forces, right? If you apply tension, any tension forces here, it's gonna split into two, right? But if you use the steel bars in the beam in this concrete here, it's gonna make it strong in the both way, right? So we use these steel bars. We use the steel bars in the concrete here in order for us to make this concrete to resist both tension forces and also the compressive forces, right? Okay. So this is just the basic understanding, right? And this is what I'm saying here, right? So I'm gonna show you all the components first of all before I use MATLAB coding. I'm gonna show you all the components. So we have two types of reinforcements here. We have the single reinforcements, the cheapest one, and also we have the doubly reinforcements, right? This requires a lot of economy, but I'm gonna show that I'm gonna create a MATLAB code that show us which reinforcement we should use according to our given parameters, right? All right. So the B is the width of the concrete beam. The H represent the height of the concrete beam, and these three black dots say they can change. They can be two. They can be one. Right. So this represents the steel bars, right? And the HS here is the cross section area, right, of this reinforcement here, right? And if we move on to the W reinforcement, we will see that all the components they are the same, but we have extra components. Like we have the A apostrophe S. This represent the area of the C reinforcement, right? And this D is also effective depth caused by this area here, right? And all of other components remain the same, right? So this is the definition, and this is why this what I told you before. The difference between the single and the double reinforcement is we use double reinforcements, right? Just we need our beam. We reinforce our beam by using steel bars in tension zone, right? Like at the bottom here, right? But if you wanna use the double reinforcements, you have to reinforce our beam here, our concrete beam here, in both compression zone and also tension zone, right? So this is the difference between single and double reinforcement, right? So I'm gonna go with Matlab and I'm gonna use the error code. So error codes give us the different formula how to find the area. Like here, to find the area at the AS and find other components, right? So I'm gonna change the view. I'm gonna change the screen, and I'm gonna change the screen, right? Okay, so this is Matlab, and as you can see, I started already coding. I just showed the component that you have, like everything that you have here. I will use CLC just to clean the command window, and the clear to clean the workspace here. So this is the first step of coding, right? You have to make sure that's the command window and also the workspace they're clean. And the parameter that I have I have B. I have B, right? For the beam, I explained here is 0.3. It's meter. The height also is 0.5. It's also in meter. The unit is meter. The D, the effective depth, is also 0.45. It's meter. FC. So FC is the strength of concrete. So FC equals 25 means that the grades of the concrete that we are using is 25 because we have different grades of concrete, right? So the one that we are using is 25. And FY is also the strength of the steel bars, right? Is 400, right? And the FC and FY, the unit is MPa, megapascal, right? Megapascal. And the M is the moment. So the moment equals to the to force which is kilonewton, times the distance, which is m. So the unit of the moment is equals to kilonewton meter, right? So this is all the components that you have to have before you find out which reinforcements you have to use, right? So the second step that you have to find, you need to modify the coefficients according to the Europe code. So you have to modify the safety factor for the concrete and the safety factor also for the steel bars, right? So I'm gonna name it gamma. I'm gonna okay, let's say the safety factor, safety factor, right? Safety factors, right? For both concrete and steel bars. So we have to understand it, right? So I'm gonna start with gamma. I'm gonna say gamma C to represent the safety factor for the concrete, right? I'm gonna take according to the code. I'm gonna take 1.5. I'm gonna take 1.5. This one is for concrete. This C represents concrete, and I'm gonna take also gamma S to represent the steel bars is 1.5, right? And I don't want to display it, right? So this is the safety factor to modify the concrete and to modify the steel, right? So after this part, the next step that you need to import is we have to calculate the cross section area, the cross section properties, right? So I'm gonna say cross section sectional area calculation, right? Calculation, right? And here, first of all, we have to find the AC. So our AC here, right? So our AC is the area of the concrete. So the area of concrete goes to B, of course, obviously B times D, right? B times D. This is the I have to find the area of the concrete, the area of the concrete, and also we have to find the initial area of the tensile reinforcements, right? Of the tensile reinforcements, right? So I'm gonna start with 0. So if I give any information here, I'm gonna say this is the area, the initial area, right? Let's say this is the initial area of tension, right? Of tension, and I'm gonna take the AS. I'm gonna take the SC. I'm gonna take AS. Let's say AS CP. CP, right? I'm gonna take the ASCP. It goes also to 0. So this ASCP here, I'm gonna define it. Like I'm gonna give information. Like if I use if I use percentage, it means that I'm gonna just give comments. So it's not that important, right? So I'm gonna also say it's the initial. Can I say it's initial area also for of compression, right? Of compression, right? So this is how you can calculate the cross section, the cross sectional area calculation. So this is how you have to do it, right? So this is how you have to do it, right? Sorry. So this is the area. This is the area of our cross section beam of our beam, right? This is the area, and this is the different area of initial of tension and compression, right? This is the AS I give to you, and this is the AS prime that I showed you before, right? Do you remember? The AS of apostrophe. Okay. So after this, you have to come up. So you have to decide. Let's say you have to design. You have to design a singly reinforcement first of all. So you have to come up with if loop, right? Like by if I mean okay, let's say, because our objective is to, according to the given data that we have, we need to find out which reinforcement is better for us to use in order for us to save money, and also to assure the stability of our design, right? The safety of our design, right? So what I'm gonna say here, I'm gonna say design of let's say singly reinforcement, right? Single reinforcement. And here I'm gonna play with the moment first of all. I'm gonna use too much moment, different moments, so you'll understand. So so in order for me to use the single reinforcement, right? In order for me to use the single reinforcement, our M, like let's say our MRD. So this MRD, right, represents the moment capacity. I'm gonna show you, I'm gonna give the comments later. So this our MRD should be equals to, according to the codes, like this formula is from the codes, Europe codes, right? Equal to 0.87, right? And this 0.7, this 0.87 should be multiply the Fy. I define the Fy, and I mean, sorry, it should define FC, because we're using the moments of we're using the moment capacity, so you have to use the concrete strength first of all. So equals to MC equals to 0.87 times FC. You have to take it times also the area of the concrete, right? The area times the area of the concrete, and also we have to take the effective depth, the half of this effective depth. So I'm gonna just say G divided by 2, right? And I don't want to display it. Right? So this is, if I give a comment, I'm gonna say this is the moment capacity. This is the moment capacity, right? This is the moment capacity, right? Okay, and so this should be this answer, the answer that you have to give here, right? You have to get it, like if the answer that we need to find for the moment capacity. So let's say if the given moment, the 50 here kilonewton meter, right, is less or equals, let's say equals to m, let's say mrd, right? So our results should display, let's say singly let's say reinforcement, reinforcements, right? All right, so this is our first condition. This is our first condition, right? And I don't want to display it right now. Sorry, I don't want to display it right now, right? Oh, sorry, I don't want to display it right now. Okay. And I can use also another one here, so I can just cut it here and then say else, right? Let's say else here I'm gonna calculate the required area of the tensile reinforcement, right? So what I'm gonna do here, I'm gonna say ms, because I need to define ms here. Sorry, I need to define the ms here, right? ms here. So our ms here should be, so ms represents, our ms here represent the required moments carried by steel bars. You know what I'm saying, right? So ms here should be m. I'm gonna take m, right, minus the m. Okay, let's mrd, right? mrd, right? And the as, the cross section area, or cross section area should be equals, so should be equals to ms, right, that we defined so far, and it should be divided by these values, like if I remember clearly, I'm gonna take 0.87, right, times the strength of the steel bars, right, and then times the effective depth, right, minus, I'm gonna take 0.4 according to the codes, right, the coefficient 0.4 times d, right? So d, right, so d equals to d minus 0.4 times d, right? So this is what I'm gonna use here now, and I don't want to display it, so I'm gonna just use this sign here. So this is as I said, this AS is the required area of tensile. tensor reinforcement I told you, right? And this ms here is the required moment, right? Let me give definition here. Let me just say this required moment, right? And this is the required area. Okay, there's nothing new here. All right. This area should be of tensor, right? Of tensor. Okay. And I can end my condition, right? So this is how you can design the singly reinforcements, right? We can do the same process with the different ideas for the double reinforcements, right? So from here, I'm gonna design also the double reinforcement. So the next step after this is the doubly, okay, let's say design of double reinforcements, right? Design of doubly reinforcements, all right? And from here, I'm gonna start with if. I'm gonna start with the condition if. So I'm gonna take if our cross-section area, okay, our cross-section area, right, as it should be equals or vice versa 0, right? So if our cross-section area equals to 0, right, it should lead to, right? Listen up, guys, carefully. Yeah, listen up very like carefully, right? So it should be lead to the area of tension reinforcements required to resist the compression forces, right? So I'm gonna say this AS here, right? This AS here should be equals, right? I'm gonna take the equals the given moment divided, because with the moments we can find the shear, we can find the bending, right? We can find the bending. So I'm gonna take m. I'm gonna divide m by the value of 0 0.0, let's 0.87, sorry, 0.87, right? And I'm gonna times it. Fy, and I'm gonna also times it times let me see, I'm gonna take, let's just say d here minus 0.4 times d again, like the same formula that I used before, times d again, right? So this should be our first condition, right? And I'm using this AS here, this cross section here, right? For the tension, for the tension, first of all, for the tension in double reinforcement, right? So I'm gonna just repeat the same condition here, right? I'm gonna repeat the same condition, and I don't want to display it. I'm gonna put this sign, and then I'm gonna go up here. I'm gonna go down here, right? I'm gonna go down here, and I can just end the first condition. I can just end this. Right? But I also need to check for the compression forces. So I'm gonna check. Let's say I'm gonna check if the compression. Let's say if reinforcement, let's say reinforcement is needed. Is needed, right? Because I just gave a condition for the this area. It's only for the tension, right? This is for the, as I say, the required area of tension, right? But I just wanna, for the double reinforcements, right, I need to have also the compression reinforcements here. So I'm gonna come up with another condition, right? So my condition here is kind of simple. My condition is kind of simple. I'm gonna just take if, right? If the AS that I have before, or AS that I have before here, right, is times, like I'm gonna take is times, let's say let me see which parameter that I should use here, right? I'm gonna say if times fy, and if these values, right, if these values they are greater, let's say they're greater than the value of 0. According to the code 0.36, right? 0.6 times the FC, the concrete strength, and then also times the area, AS, right? The AS that we give this AS here, right? The section of our beam, of our concrete beam, right? So if this condition, right? If this part in here is greater than this part, right? I should calculate the required area. I should calculate the required area compressive reinforcement, right? You know what I'm saying, right? So I'm gonna go, because I give if condition already, so I'm gonna say A, like S, let's say, let me give any name, like S, CP, right? Which represent the required area, as I said, the required area of compression, right? I'm gonna take equals, right? I'm gonna use it equals to 0.36. I mean 36, and I'm gonna times the FCK. I mean FC, right? FC, and times, of course, the area. And I'm gonna divide these values by the value. I'm gonna divide by the value of the strength of the steel bars that we're using here, right? So this is how you can create your condition. And if this condition match, right, I need to find. So I need to display. My answer should be, I need to display that. Let's say that let's say the compression. The compression reinforcement is required. Is needed. Let's say it's needed, right? Is needed, right? So I can just give an example, and the area, and the area, the area equals to, I can just give any value, right? I can just give any value, and I can modify those value to the the string number. I can modify this value to the string number. So I'm going to say the area. Okay, the area here, let's say okay, I can just modify this the value that I'm gonna find there into string, because all of the other values are string, right? So they're supposed to match. So I'm gonna modify it by using number str to modify in string, right? And I'm gonna take the value ASCP, right? I need to modify the value of ASP into string, right? And the unit should be millimeter. Of course, I'm gonna take millimeter. Sorry, and here the unit should be millimeter. And the unit here, I'm gonna take the units in millimeter. It should be millimeter square, by the way, not millimeter. Millimeter square here. Okay. Yeah. So this is how you can create. This is how you can check the compressive reinforcement if it's needed, right? If it is needed, right? And here, and here, right? Okay, let me just say this. Just give better information than ends. I can just use this one to show, like, to separate them, right? So it's okay, no problem, right? And this is how you can display if the compression reinforcement, right, is needed. So this is how you can come up with any codes, right? And it's not over yet. So I need to find also the reinforcement type, right? After this code here. So at the end of this code, I need to do the other one. Like I need to determine the reinforce type here. So let's say the next step is to, let's say, determine the reinforce, like let's say the reinforcement type, the reinforcement type here, right? So and here I'm gonna use if condition also. I'm gonna use if, right? If our a s, right, our scp, right, is greater, let's say is greater than the area, right? Is greater than area. So we have to display. We need to display. Let's say we need to display like we have to use. Let's say we have to use. You have to use compression reinforcement. All right. Reinforcement. You have to use compression. Otherwise, right? So otherwise, we have to display. We need to display. We have to use the tension reinforcement. We need to use the tension reinforcements. Okay, reinforcements. Okay. So this is how you can find it, and then you can end. You can end the value. You can end the value here. You can just end this comment here. Also, we need to end the first comment here that we started. But before I end this, before I end this comment here, I need to give other condition here, because I give only the first condition here. Like when this area, when this value here that greater than this, I need to display. I need to use any compression reinforcements here, right? But I have another one. I have another formula. I can just use. I have another condition, right? I can just use else, right? Otherwise, right? Otherwise, we have to display like use tension, use tension, use tension reinforcements only, right? Let's say only, right? So this is how you can create this is how you can know which kind of reinforcements you have to use using MATLAB coding, right? And this is the end. But to make it more spicy, like more like professional, you can display the results separately, right? So we can just end, first of all, we can end this condition, and then we can display the condition. Like we can just say we can display the result separately, like display. And from here you can try to put some important information, like the required area, of tension, right? The required area of tension reinforcement. So and here, yeah, you can give a space here where you can put any value that you wanna do, and this value should be modified, should be changed, like convert into string value. So I'm gonna convert them into string value by using this code, right? And the value that I need to change is the value of the area, the AS, the cross section area, and the value should be also in millimeter, and the value also should be in millimeter, right? The value should be millimeter. Okay, millimeter square, millimeter square, millimeter square. And this is how you can come up with a code that's help you to find which kind of reinforcements you should use. And to check the results, you just go on editor and go to run. And you have to save, first of all, you have to save your work. They're gonna ask me, the computer gonna ask me to save. This is how. So we can just save. We can just type any name. We can just say beam, beam 1, right? And then just save your work. And if there's a mistake, you have to change. You have to change the mistake, right? And if there's no mistake, right, we have to raise the results, right? Like for me here, this is my results. Like the compression reinforced according to the given data that I have here, right? The given parameters, right? So if I want to design my concrete with these values, with these parameters here, so I need the compression reinforcement area should be 0.0000 I mean 0.0003037.5 millimeter square, and I need to use the tension reinforcement, and the requirement of the tension reinforcement area should be also 0.52511. So this means that okay, this mean that I can only use the single reinforcement, right? I can only use the single reinforcement. All right. Yeah, if you come here, right? I can only use these parts, and they give me this how much value this area should be. This area should be here, right? In order for me to make this one stable, this concrete here reinforced. So this is the meaning of what everything about the reinforcement concrete beam, right? So if you find this video entertaining, guys, I beg you, subscribe to the channel, like the video, and also share the video. I'll see you in the next one. Bye bye.